Okay, good morning, 6 years. I wanted to run through corrections from work that I posted for you on Thursday. So these were from page 307, page 308 of your textbook. And you can see the problems there 1, 3, 9, 14, 16. So these are all based around the count of permutations section that we looked at over the last couple of days. And a couple of people got back to me saying that they're having a couple of issues with them. So I wanted to run through corrections there. So, first question, a simple investigation. So it gives you a statement and you have to figure out whether it's correct or not. So when we have this little exclamation mark, it means factorial. Okay. So we've got 4 factorial, for example. That means that what we do is that we multiply it out step by step all the way down to 1. So we start with 4 and we go multiplied by 3, multiplied by 2, multiplied by 1. So there's that many options. What we can use with this, we can use this to figure out loads of different stuff. And you can see in this case it's 24. So there's 24 possibilities if you want to think about it this way. So you can imagine if I had a 4-digit number and I could use any of the numbers 1, 2, 3 or 4, but I could use each one of them only once. So you could have loads of different instances, and a simple way to work this out is by using this factorial process. So you can imagine, let's say I would have 4 choices here. To pick my first number, I could have 1 or 2 or 3 or 4. Now remember, I can only use each one once. So if I use 1, for example, then I can't use that in my second digit. So that means I've only got 2 or 3 or 4 left. 2, 3 or 4, which means there's 3 options left. And then if I use 2, there's only 2 options left, 3 and 4. And then if I use 3, there's only 1 option left. So you can see that becomes the 4 by 3 by 2 by 1. And it gives me all of the possibilities in that instance. So that's what the idea of a factorial means. So there's 24 possible ways that I could write that 4-digit number using 1, 2, 3 and 4. So we can do that, and again there's a factorial button on your calculators. I think you just have to hit the shift button and you'll find it. It's an N with a exclamation mark on it if you're using a Sharp. And if you're using a Casio calculator, it's an X, but it's the same thing. It's X with an exclamation mark. Okay, so either of those, but you'll find it anyway. So all you got to do is pop that into your calculator. Alternatively, you can do it this way into your calculator as well. If you know that you're starting with 4, you can just go 4 by 3 by 2 until you get back to 1. And you can do it with 5 and you can do it with 9. And you can see I've done it there. Okay, and the only thing to keep in mind, the bigger the number, the larger the number of possibilities or permutations that we have here. Loads and loads of big numbers involved when the factorial number is large. Alright, so we can see in this case then that 4 factorial plus 5 factorial does not equal to 9 factorial. Same process here. I've got 3 factorial multiplied by 4 factorial. So again, 3 factorial is 6, 4 factorial is 24, 12 factorial is this number here, 479,001,600. So again, the bigger the factorial number, the larger the amount of permutations. So you can see how big that can get. Alright, so that's the idea of a factorial and how it works. With question 3 then, it's asking about arranging the letters of the word games. So we can see that we've got G, A, M, E and S there, and it tells me that when we're rearranging these, they have to start and end with a vowel. So the vowels in this word are A and E. So I can have A at the start and E at the end, or I could have E at the start and A at the end. And what I've done then is I've just written out all the different permutations that I could have. Now there's no real way of any kind of surefire way to set this out. You just got to do it. You got to write it out step by step and see how you go. Just make sure you take your time, be careful. So you can see what I've done here. I've started with G, then I moved S to the front, then I moved M to the front to make sure that I don't miss any. I'm not just plucking them out of the air. I'm starting with G and then I put the other ones in order then I rearrange them. So you can see I start with G, then I've got M, then I've got S. So that was my first one. And then I rearranged the M and the S. Then I went with S to the start and rearranged, and M to the start and rearranged. Now you'll notice that line, the top lines are the same, and the second ones are the same. So they repeat one another. All that's happened is that the E and the A have swapped places. Okay, so I've got 12 different arrangements overall. And that was part one. How many have M in the middle? So you're just looking for which ones have M in the center, and I can see 1, 2, 3, 4. So there's 4 of them with M in the middle. 6 of them end with the letter E, because that's all of these ones on the left hand side here. 6 of them have G before S. Again, you can look through them and tick off which ones that apply, but it's 6 in this case, and then with the other way around it's 6 also, because I'm looking at 12. Okay, so if there's 6 of them that have G before S, then the other 6 have to be the other way around. And then last one's M and G when they're beside one another. There's 8 of those, so therefore there has to be 12 of them when they're not beside each other, because there's only 12. Alright, so again, there's no real surefire way of doing this, because they're going to ask you different things all of the time with different letters or different combinations of things. Just got to be careful, take your time and write out all your possible options. Once you have that done, you can answer any question that's thrown at you. Next one then, question 9. Again, we have the letter, the word square, and we are asked how many different ways can the letters of the word square be arranged. So if you're taking the letters 6 at a time, okay, so you're taking them as a whole. In this case, I can use 6 factorial, and I can just get that to 720 different ways I can rearrange that word. Now the important thing here is because there's no letters repeated. If I had a word with two of the same letter in it, that would throw off my options slightly, but just be careful of that. In the next ones then, in question 9, I asked to take the letters 5 at a time. So I can take 5 of the 6. Okay, so you can see here I've asked you to use this NPR button. So again, the P represents permutations really. Okay, but sometimes I think about it as pick. So it's permutations, but sometimes I think of it as pick, because you're picking 5 of the 6. Okay, taking 5 letters at a time. So the way to do it, you can see I can use the 6 options, but I'm only taking 5. So I can do it's essentially the same as the way you would do factorial. Sorry, that's written wrong. That should be 720 as well. I've just written it the wrong way around. Apologies. Very similar to factorial, but it stops quicker, because if I'm only taking 5 in this case for part 2 question 9, I'm only taking 5 letters, but I do have 6 to choose from. S, Q, U, A, R and E. So I can pick any of those 6 to start off with, and then I can pick 5, and then I can pick 4, and then I can pick 3, and then I can pick 2, and that's where it finishes. So that's why I've got 6 by 5 by 4 by 3 by 2. Okay, so there's the amount of spots. So you can use that NPR button again. You have to use shift or your second function to get it on your Casio or your Sharp. And in part 3 it asks for 2, taking letters 2 at a time. Okay, so it's 6 by 5 in that case. 30 different ways we can do that. Question 14 asks about studying subjects. So you've got 7 different subjects and you have to pick 4 of them to study on one day. So the first one, it says there's no restrictions to what subjects you can pick. So you've got 7 subjects and I'm picking 4 from them. So it's 7 by 6 by 5 by 4. It gives me that many options in the orders of which way I could study. Part 2, it says you have to start with maths. So the first number has to be 1, because there's only one option, maths. Then after that there's 6 different options, then 5 different options, then 4 different options. So you multiply it out that way. In part 3, you must not start with maths. So I can pick any subject at the start except for maths. So there's 6 different options. And then, because I've picked maths first, there's still 6 options to pick from. So I do 6 by 6 by 5 by 4. in part 4, you're asked about a language. You have to start with a language. So there's English, Irish, and French are the languages that she studies, Karen studies in the question. So you can pick 3 of the languages to start off with. So that's why 3 is our first number here. And then 6, because there's 6 options after that. I've only picked English or Irish or French. And then there's all the rest of the subjects that she has to study. And then finally in part 5 there, she must not start with a language. So 4 of the subjects that she studies aren't languages. So that's why 4 is the first number. Then I can pick whatever I want. I can do any language second if you want to. So that's the way to do it. It takes a bit of time to get used to it. But again, there's plenty more practice to be done on the revision exercises on the exam paper questions if you so wish. And then finally, question 16, it asks about a password for the computer system consists of 3 different digits followed by 2 different capital letters. So 3 different digits. Remember, we can have anything from 0 up to 9. So that means there's 10 possible digits that I can use. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 gives me 10 options there. And it says you can use 2 different capital letters. So there's 26 options, because there's 26 letters in the alphabet. Okay, so part 1 asks how many different passwords are possible. So the same idea here. Look, I've got number, letter. There's 10 different options for pick 1. Then there's 9 options. Then there's 8 options. When I get to the letters, then I have to multiply by the amount of letters I have in the alphabet, because there's 26 options for the first letter that I use, and then there's 25 options for the second letter that I use. I just multiply all those together and I get that 468,000 combinations that there could be. The last part of this problem then says Ian forgets his password but knows that the first number is 5 and that the last letter is A. So how many different passwords fit in here? So again, you know that 5 has to be at the start, so that's why there's a 1 there. You know that A has to be at the end, so that's why there's a 1 there. And then we have all the different options in the middle. So there's 9 options, because I can't pick 5 to put in here. So there's 9 of the 10 I can pick. Then there's 8 of the 10 I can pick left over, because 5 and another number have been used already. And A is going to be used, so there's only 25 options to pop into here. So you can see I've got 1 by 9 by 8 by 25, and that gives you 1800 options that start with 5 and end with A. Thank you very much.